Hello everybody. This video looks at Arc and Mutex. We're going to write some concurrent Rust code with Arc, Mutex, and we're going to be updating data. It'll be a concurrent Rust program using threads, Arc and Mutex. It's going to update shared data, and it's going to increment an additional underscore info value. It's going to ensure thread safety with Mutex, and then at the end, we'll print the final state of the shared data once the threads are finished. Let's start the code. Let's start a new Rust project. We'll call it Arc3. Change into source. And then we'll begin with editing main. And there's a new version of Rust Analyzer, so let's install that. Okay, so first thing we want to do is we want to do the imports. So let's use standard sync. And we're going to use Arc Mutex. Use standard thread. And we'll also use, we'll use anyhow. And result. We'll get an error because we've not imported anyhow. Do cargo add anyhow. I'll get rid of the error. Just save it. There we go. Right, so we want to create a struct, which we'll call struct shared data. And we'll have a field called content. We'll make that a string. Same as the earlier video if you saw that. And we'll have another one. Let's add another one just for additional info. And let's make that I32. Okay, and we will print this, so let's add derive debug. Okay, see if that compiles. Yeah, we got the usual. Let's just, while we're at this point, let's just add hashbang allow unused. Right, let's get rid of all of those. Cool. Okay. Okay, impl shared data. Let's create a new function. And it will return self. Within that, we want it to return shared data. And let's add in content will be initial content. And then additional info can be add info. We need to close that one. And then we need to actually put in some values, some parameters into here. So we will call the initial content and the other one is called add info. So add info I32. And I think we need a closing parenthesis there. And there's something not right there. Let's see what that is. Oh, we need to make the initial content just here. We need to make that a string. So it's a string. Good, that compiles. And then let's just format that because that's not looking too pretty. FMT. Good. Okay. So that's our constructor for the shared data struct. And next, we probably want to be able to update it. just a little side note, when doing this bit to push string to basically append to the string, which is the content, you need to use ampersand before the format because push string method expects a reference to a ampersand str, lowercase str. So you have to put in the ampersand there. Without the ampersand, you have a bad time. And actually, it says expected ampersand found string. It doesn't actually tell you how to fix it, but yeah. So what you need to do is put in the ampersand there, and then it compiles. So just a little hint. Okay, so let's create a shared data equals, and let's kind of begin with the structs. So we go shared data. We use the new function. The initial content will be the initial content, and the add info can be 42. No surprise there. Okay, and then we need to I'm just going to do this ahead of time, so I'm going to put the two closing brackets there, and then we need to put mutex new here, and then around that we do arc new. That looks okay. Compile. Yep. So this is kind of wrapping a bit because I'm making the font bigger for the video. So yeah. Right, good. Okay, we've got the shared data variable. Okay, so let's do the thread work. That's going to be the closure, and let's pass in data, which will be arc with mutex shared data, and we also want to pass in the thread ID, which will be 32. So far, so good. Okay, so let's add something to the closure. Okay, so let's put the body of the closure in here. So we need to say let locked data, creating a new variable called locked data equal shared data dot lock. So we're taking over the lock on the shared data. And I think I've added in result and OK. So will it anyhow cope with that? No, it doesn't appear to. So let's just stick with unwrap for the time being. Okay, that seems to be okay. So now we can do we need to update the content. So lock data, then we use the update content function and we pass in the thread ID. And it doesn't like that for some reason. Lock data needs to be mutable. There we go. Right, good. Okay, so we've got shared data wrapped in an arc and a mutex, and we have defined a closure to do the thread work. So the code so far, we initialize shared data using Arc and Mutex, then define a closure for the concurrent thread work that updates the shared data using a mutex lock. The code structure is present, but thread spawning and complete error handling are not yet implemented. Okay, so let's use the thread. So for I in naught equals 0 up to 3. With data equals arc clone, then shared data. Then we want to do handles dot push. And this is where we do the thread spawn. And then we need to do the move. And thread work. We need to pass in data and I. Expected one argument found 2. Yeah, I thought that was wrong. Right, that should work. No? Let's try and compile it, see what the problem is. Unclosed delimiter mismatch. Isn't it always? So getting closer. So shared data is borrowed here. Right. Bear with me. I'll be back in a second. I need to think about this. Okay, I think I found the problem. We've got shared data here, which is the actual data wrapped by the arc and the mutex. What we really need is the data from inside. And that's it. That's fixed it. Good. It compiles. So we've spawned the threads, and then all that will then remain is to. So here we're updating them because we're using the thread work, which does the update content, which is doing this, which is pushing the thread ID to the string and keeps building it up, appending to it. And then we just need to do the join handles at the end. Okay, so now we want to wait for the threads to finish. So wait for threads to complete. And we can say for handle in handles, handle dot join, and we use unwrap. Okay. And then we will just need to take the lock and print. Okay, so now we can do let result equal, and then we take the shared data, take over the lock, we unwrap it, and then we can print result, which is going to be effectively our struct, and then we can print the content, and then we can print the additional info as well. All being well, that will compile. Let's just format it again. Okay. Turn off the inlay hints, and let's compile it. And the initial content 102. Yeah, because I'm adding the thread ID to the initial content each time, which is fine. It's not formatted particularly nicely. Let's just tidy that up. Which we do with the update content function, which is there. So if we just go in and put a space there, and again, here we go. The initial content, then we go 0, 1, 2. So we're appending the thread ID to the content, and the threads aren't getting out of order. There we go. I thought it should do that. If you run it enough times, you will. I think if you saw my earlier video, you'll see that threads are kind of non-deterministic, so they don't always run in order. The 45, so that was the 42 that we started with. And that just gets incremented by 1 each time using this line here. So it started off at 42. There we go. On this line here, we started with the initial content in 42, and then each thread added 1 to the additional info, which is an I32, and also updated the content by adding the thread ID. So that's where we get the initial content, and then 0, 1, 2, or whatever order it runs in, 0, 2, 1, 0, 2, 1. Let's run it again, 0, 1, 2. Good. Right. Well, hopefully this has been interesting, and hopefully I've explained each line as best I can. It's quite a lot to take in and get your head around, and I still won't be able to type this from scratch tomorrow, but I think it's something to kind of revisit and recall, repetition, and so on. I think even if you can just delete a little section of it and then type it back in, it's pretty much the best way to find out what it is that you've forgotten, or which bit you're not actually understanding and storing in long-term memory. So yeah, repeat this. Come back the day after. Maybe watch this video in a week's time, 2 weeks' time, month's time, so on. So yeah, thanks for watching, and yeah, hopefully you're enjoying these kind of sequential videos which build upon the earlier ones. So yeah, thanks for watching.